Hello, everyone. My name is Amina. I work at The Guardian as an associate software engineer on the Digital Fellowship Program. Today, we're going to be looking at classes and objects in Scala. So let's get started. Let's imagine that we're tired of lockdown and we want to plan our next holiday. So we're going to use Scala to help us plan this fantastic getaway. As a starting point, let's think about where we want to go. Why don't we create a blueprint that describes the potential places we could go? How could Scala help us with that? Well, we could start by creating a class which acts as a template for creating objects. Let's call our class destination. So we've got our class, but how can we create an object, an instance of that class from it? Well, in Scala, we can use the new keyword, and there we go, we have our first instance. We can make our class more useful by adding a parameter to it. Scala has a strong static type system, which means that we need to state the type of our parameter. Let's make our first parameter a string, and it's going to be called country. So, given our new class, let's create an object. Again, we're going to use the new keyword, and we'll pass in a string in order to follow the contract of the destination class. And we're going to make this destination Nigeria. Let's add another parameter to make our class more useful. We're going to add a second parameter of type int, which is a number. We'll use this parameter to store the price of the flight. This is great because now we have another field on our class, so we can hold more useful information. But the compiler is giving us an error when we instantiate our class with parameters in the wrong order. You can see that country is the first parameter and the second is flight price. So to remedy this, we can introduce named parameters when we instantiate our object. This means that we can change the ordering of the parameters and the Scala compiler can identify them. This is great because it means that when we create a new instance, the order of our arguments don't matter as long as we name them. We've now got two parameters on the class, country and flight price, but we can make them more useful by defining them as variables. In this case, we've used the val keyword to create an immutable field. If we define our parameters in this way, it means that we can call them on objects to return their value, which is really convenient. So after creating a new instance called Nairobi, we can call country on it and we'll receive the value Kenya. We can also make use of default parameters. Default parameters set a default value for a field without it being set when the object is instantiated. In this example, we've created a new parameter called with loved ones that returns a Boolean, true or false. This means that if we have any friends or family in a particular destination, our object will record this. We've set this parameter to false, which means that without declaring it true for an object, it will always be false. Here, we create a new instance called Nairobi, and we comply with the contract of the class by giving this object a country and flight price. However, when we call with loved ones on the Nairobi object, we get the default value of false. This is useful because it means we only declare this parameter if true, and it saves us a few letters of code. If we get tired of typing the new keyword when instantiating our destination class, we can create something called a companion object. The companion object has to be the same name as our class, so here it's called destination. And in the companion object, we can define an apply method. This means that when creating a new instance, we no longer need to use the repetitive new keyword. Here, we create a new variable called Dakar, and we set this to a new instance of destination with the country argument set to Senegal, and we haven't had to use the new keyword. Companion objects have lots of helpful uses. Another of them is that both the companion object and class can access each other's private fields and methods. Here, we create a private method within our class called family flight cost. This method calculates the total cost of our flights for a family of 3. We've defined this private method in our class, which means that typically only the class would have access to it. But because we've created a companion object, this also has access to it. If we create a new instance of our class inside the object, we can now call the method family flight cost. Now let's take a look at case classes. Case classes are like regular classes, but with a few key advantages that are going to make our holiday planning easier. First, when we create a case class with parameters, in this case, the parameter being country of type string, this parameter is automatically created as an immutable field. The good thing about this is that it has an accessor method built in, so we can call it on our new instances. You can see here that we call country on the Abidjan instance, and we get the value of this field, Côte d'Ivoire, as a result. This is helpful because it means that we don't have to use the val keyword like we did with normal classes. Second, case classes come with an apply method already created in their companion objects. So that means that we can instantiate a case class without using the new keyword. When we used a class for our destination, we had to write a few lines of code to create an apply method in our companion object, but we can get this for free with case classes. A final interesting point about case classes is that instances of case classes are compared by their field values and not by their names. This means that if we create two different instances of a case class with the same field values but different names, they are equal. In the code example here, we test this by creating two instances with different names, Abidjan and made-up name. They both have the same fields because Côte d'Ivoire is the value of the field country for both of them. Nevertheless, they are both considered the same in Scala, despite them having different names because the value of their fields are exactly the same. Another interesting thing we can do with Scala is to use traits. A trait is where we can design an interface without having to implement its behavior. In this case, we've created a trait called cost. This holds a method which does not have an implementation. We can use this trait on any class that we like. We just need to make sure that within that class, we provide an implementation. Here, we've created 3 classes: flight, accommodation, and packing list. All of them extend the cost trait, and they do this by using the extends keyword. So, how does each of them implement the cost method, which is undefined in the trait? Well, the 2 case classes do this by creating a parameter called cost, which is of type int. Remember that with case classes, the parameters are public vals with accessor methods by default. So, by creating cost parameters in our case classes, we've already provided an implementation to this method. The class packing list implements the cost method in the class body. Traits are really helpful because it means that all of these different classes can benefit from the same method. This becomes particularly helpful when we want to modularize our code because we can extend more than one trait on a class. We can therefore design different functionalities and plug them into our classes as we like. In this example, we test this by creating a list called holiday made up of our 3 different classes, And we're able to use the cost trait to sum all the different costs across these classes, giving us the value 1225. So, in this lightning talk, we've spoken about creating a class, creating an instance of a class. We've looked at named and default parameters, companion objects, case classes, and traits. I hope you've enjoyed this, and do look out for more Scala videos to come, which I hope to put on my YouTube channel. So do follow me on Twitter to find out more about those. Thank you.